So, in this topic, we are going to study ఏమ్మా ఎవరు గీత గీయద్దు.
సార్ మిమ్మల్ని లైవ్ చేయాలా, మిమ్మల్ని హోస్ట్ చేయాలా? ల్యాప్టాప్ నుంచే కదా
సార్ ఇది అందరికి ఓపెన్ అయినట్టుంది సార్ ఇది స్క్రీన్.
మీరు హోస్ట్ మీరు ఏమైనా చేయొచ్చు ఇక. మీరు డిసేబుల్ చేయండి. అనోటేషన్స్
బాబు
ఎవరినా అన్నది టోటల్గా మీట్ చేసేసుకోండి అందరూ.
సో today topic is heterocyclic compounds. We are going to discuss introduction of heterocyclic compounds, classification.
సార్ నేను లీవ్ వల్ల మళ్ళీ అరౌండ్ 6:30కి అట్లా జాయిన్ అవుతాం.
Sorry. Of ఇది అందరికి ఓపెన్ అవుతున్నట్టుంది ఎగ్జిస్టింగ్ వైట్ బుక్.
ఇప్పుడు చేయండి ఒకసారి. ఓన్లీ హోస్ట్ కావాలి.
బాబు మీరు ఇట్లా గీతలు గీస్తే కష్టం అవుతుందమ్మా.
సరే సెట్టింగ్స్ లో చూస్తాను.
రైట్. పిల్లలు స్క్రీన్ యూజ్ చేయకండి, మీరు చూడండి అంతే. ఏదైనా మీరు రాయాలనుకుంటే చాట్ బాక్స్లో పెట్టండి, ఓకేనా? సో heterocyclic compounds. Okay. Today we will discuss about introduction of heterocyclic compounds. Next one, classification of heterocyclic compounds. Next one, preparation and properties of heterocyclic compounds, that is pyrrole, furan, thiophene and pyridine. Next one, the most important one is comparative study. Comparative study of heterocyclic compounds and discussion about previous questions, right? So next one is right. Okay. So introduction. introduction of heterocyclic compounds. Okay, right. First one, what are heterocyclic compounds? So please write in inbox. Inbox ikkada sir. Right. Babu mention చేయండి అన్న. What are heterocyclic compounds? Okay. Third box లో మెన్షన్ చేయండి. Right. Generally organic compounds consisting with carbon and hydrogen elements. So carbon and hydrogen is the main element in organic compounds. So suppose this is the carbon chain. It contains 1, 2, 3, 4, 5, 6 carbon atoms. So these two carbon atoms are called terminal carbon atoms. Whenever these two carbon atoms combined with each other, it means these two carbon atoms combined with each other, these are called cyclic organic compounds. Suppose 1, 2, 3, 4, 5, 6. So like this. So these two carbon atoms, these two terminal carbon atoms are do not linked with each other. This is known as open cyclic or acyclic organic compounds. Acyclic organic compounds and cyclic organic compounds. So these cyclic organic compounds consisting with only carbon atoms. It means only carbon atoms in cyclic system. That is known as carbocyclic compounds. Okay. Suppose the cyclic organic system consisting with only carbon atoms. That is carbocyclic compounds. Suppose the cyclic organic system or carbocyclic system contains at least one atom other than carbon atom. At least one atom other than carbon atom, that is known as heterocyclic compounds. Okay. So organic compounds, organic cyclic system consisting at least one atom other than carbon atom, that is known as heterocyclic compounds. So generally సార్ ఇంకోటి యాడ్ చేయాలంటే ఎట్లా? Sorry. Sorry. Okay. Right. Okay. Suppose. So these are the heterocyclic compounds. Right. So the X is the heteroatom. The other than carbon atom is called heteroatom. So general heteroatoms are nitrogen, oxygen, sulfur, okay, silicon, aluminum, germanium, phosphorus, etc. Okay. So these three atoms, okay, these three atoms, so these three atoms are very common in organic compounds. Nitrogen, oxygen, and sulfur. These three atoms are very common in heterocyclic compounds. General examples are, sorry, right, pyrrole, furan, thiophene, pyridine, etc. So, pyrrole molecule and furan molecule, thiophene molecule, and pyridine molecule. So, these are the general heterocyclic compounds. Okay. So, next one, classification. Classification of heterocyclic compounds. So, classification based on number of atoms present in cyclic system. Second one is nature of heteroatom. So classification mainly depends on number and nature. Okay, number and nature of heteroatoms. For example, right. Okay. So based on number and nature of system, three-membered cyclic system or three-membered heterocyclic compounds. Okay, four-membered heterocyclic compounds, five-membered heterocyclic compounds, six-membered heterocyclic compounds, and seven-membered heterocyclic compounds. So in these classifications, five and six-membered heterocyclic compounds are most important one. So here, for example, best example for five-membered heterocyclic compound is pyrrole molecule. So the cyclic system including nitrogen atoms. So five-membered system means including nitrogen atom, it is comes under five-membered heterocyclic system. For example, pyridine molecule, this molecule comes under six-membered heterocyclic system. Okay, so next one, nature of based on nature. So based on nature, suppose this is the three-membered system. heteroatom is different, but cyclic system consisting with only 3 atoms. Similarly, 4-membered system having 4 number of atoms, but different at heteroatom, right? Next one is similarly 5-membered system also. Okay. Right. So based on number and nature of heteroatoms, heterocyclic compounds are classified into different types: 3-membered heterocyclic, 4-membered heterocyclic, 5-membered heterocyclic, and 6-membered heterocyclic compounds. Okay. Right. First one, what are heterocyclic compounds? Second one is, what are the examples of heterocyclic compounds? Sorry, 5-membered. 5-membered right. Okay. Give the answers for what are carbocyclic compounds, what are heterocyclic compounds. Give an example for 5-membered heterocyclic compounds. Okay. So please mention in chat box or comment box. So what are carbocyclic compounds? So one person has given answer, that is cyclic compound, good, which contains one or more one atom or more heteroatoms. Okay. So give examples for 5-membered heterocyclic compounds. Anybody? Right. Carbocyclic compounds are benzene and naphthalene. Very good. This is comes under carbocyclic compounds. Next one. It includes nitrogen. Very good. 5-membered heterocyclic compound. So please mention the name of the particular compound. For example, pyrrole. Pyrrole is the best example for 5-membered nitrogen containing heterocyclic compound. Okay. Any other one?
Firrol, sir.
Amma? Write in chat box.
Sir?
Please type in chat box. Furan, very good.
Puran, thiophil, sir.
Heterocyclic system, 5-membered heterocyclic system.
Thiophil, sir.
Thiophene, very good. Okay. Thiophene is 5-membered sulfur containing heterocyclic system. Anybody? Show 6-membered heterocyclic system.
Quinoline, sir. Quinoline.
Huh?
Quinoline, sir.
Quinoline. Okay,
Pyridine.
right. Pyrrole molecule, nicotine, quinoline, very good. Sorry, pyridine molecule, very good. Nicotine, quinoline, indole also. Indole is hybrid heterocyclic system, right. Okay. Next we will go for preparation. So preparation and properties. Preparation and properties of five-membered systems. So according to our syllabus, PGCET syllabus, the five-membered heterocyclic systems are: one is pyrrole molecule, second one is furan molecule, third one is thiophene molecule. Okay, pyrrole, furan, thiophene. So, right. Right. So, at the same time, we will discuss preparation properties of the three compounds, that is pyrrole, furan, and thiophene molecules. So, first one. Okay, pyrrole, okay, furan, and thiophene molecule. Right. So, general study of pyrrole molecule. First one, molecular formula. Molecular. So, molecular formula of pyrrole is C4H5N. Next one. Hey, ఎవరు బాబు ఇది ఇంట్రెస్ట్ లేకపోతే లీవ్ కాండి. Right. Furan, that is C4H4O, and thiophene C4H4S. So these are the molecular formulas of pyrrole, furan, and thiophene molecules. Next one is structure. Okay, structure of pyrrole is, right, this is the structure of pyrrole molecule. Next one, this is the structure of furan molecule. Sorry, this is the related to thiophene molecule. So numbering is like this. 1. Okay. This is 1, second, 2, 3, 4, 5. So the number starts from heteroatom. So we will give first priority to heteroatom. So in this case, first number has given to oxygen atom. You can write either left side or right side. So in case of furan molecule, I can write right side 1, 2, 3, 4, and 5. This is thiophin. The first number, where will I write? Okay. 1, 2, 3, 4, and 5. Okay. This is numbering. It has given like this. Okay. Next one. IUPAC nomenclature. This is the most important topic, but was people. So in IUPAC nomenclature for pyrrole molecule, this is the important one. For pyrrole molecule, generally prefix, you can write the IUPAC nomenclature by prefix and suffix. So in case of prefix molecule, it describes the heteroatom. For example, suppose the compound contains nitrogen atom, you can write as a, suppose it has oxygen atom, we can write also. Next one, if it is sulfur atom, we can write thia. Okay. Suffix further divided into word root and can write last letter suffix. So word root mentions the size of the ring. Suppose whether if it is 3-membered system or 4-membered, 5-membered or 6-membered, whatever it may be. In case of 5-membered system, we can write all. 6-membered system in. Okay. In case of suffix describes the degree of unsaturation, if it is saturated or unsaturated. So I can concentrate on only these three nomenclature of these three compounds. For example, it is for pyrrole molecule. Suppose it is pyrrole molecule. So IUPAC nomenclature of pyrrole is we mentioned the prefix. What prefix for nitrogen atom? As a, you can write as a for nitrogen atom. So or if it is saturated, olane, you can write olane. So as a, the suffix is all. So you can combine prefix to suffix. Before that, you can delete the last letter in prefix. So as all is the IUPAC nomenclature for pyrrole molecule. For furan molecule, instead of nitrogen, we have oxygen atom. You can mention oxa plus or. You can delete last letter in prefix. Combine the prefix combined with the suffix oxole. Oxole is the IUPAC nomenclature of furan molecule. For thiophin, thia, OLO. You can delete it. Thiol is the IUPAC. So azole is IUPAC nomenclature of pyrrole. For furan, oxole. For thiophin for thiophin molecules. Sorry, thiol for thiophin molecule. So this is about the IUPAC nomenclature of these three compounds. Okay. So
Sir.
next one,
Sir,
preparations.
voice. Hello.
Sorry.
Sir, voice is not clear, sir.
అమ్మా వినొస్తలేదు, చాట్ బాక్స్ లో మెన్షన్ చేయండి. స్క్రీన్ పైన కనిపించట్లేదా అమ్మా? ఓకే, వాయిస్ నాది కూడా ప్రాబ్లం వస్తుంది, ఎక్కడ పోతుందో అర్థం కావట్లేదు. సో ఇప్పుడు ఓకేనా అమ్మా?
Okay, sir. Okay, sir.
అమ్మా
Okay, sir.
వాయిస్ ఇప్పుడు క్లియర్గా ఉందా? వాయిస్ ఇప్పుడు క్లియర్గా ఉందా? ఓకే రైట్. పిల్లలు అర్థమవుతుందా అమ్మా? ఫాలో అవుతున్నారా? ఏదో చెప్తూ పోయినట్టుందా? ఓకే రైట్, థ్యాంక్ యూ. రైట్. సో ఇక్కడ మనం టైం వేస్ట్ కాకుండా, డిఫరెంట్ టాపిక్స్ కాకుండా, అంటే సెపరేట్ కాకుండా ఒకేసారి ప్రిపరేషన్స్ అన్ని మీకు కంపారిటివ్ స్టడీ లాగా కూడా యూజ్ అవుతాయి. ఓకే, గుర్తుపెట్టుకోవడానికి కూడా ఈజీగా ఉంటుందమ్మా. రైట్. ఫస్ట్ వన్ pyrrole తీసుకోండి, pyrrole. Second one is furan molecule. The third one is thiophene molecule. Okay, right. So first of all, so preparation. Before that, presence. Generally, the pyrrole found in hemoglobin. So pyrrole is the main element in hemoglobin. Next one, chlorophyll also. Pyropyrin ring is the framework for heme and chlorophyll skeleton system. Next one is chlorophyll. Next one is bilirubin and vitamin B12. Next one, pyrrole presence in bone oil and coal tar also. So generally, it present in the furan molecule present in polysaturated hydrocarbons are polyunsaturated fatty acids and some derivatives of amino acid derivatives. Next one is the thiophene molecule. It is present in coal tar, and this is the main impurity in commercial benzene. This is the most important one. So which of the following compound is an impurity in commercial benzene అన్నాడు అనుకోండి, you can mention A pyrrole, B furan, C thiophene, and D is pyridine అన్నారు అనుకోండి, you can write thiophene. Thiophene is the correct answer. So thiophene is an impurity in commercial benzene because of these two compounds having similar boiling points around 70 to 78. Next one is so occurrence, biological properties. Every molecule, generally heterocyclic compounds having wonderful biological activities. So generally, pyrrole molecule having inflammatory activity. So inflammatory means anti-inflammatory activity, antimicrobial, antifungal activity, antifungal, antibacterial activity also. So bacterial. So combined it is called antimicrobial activity. Anti-cancer. This is the best example for anti-cancer. One of the anti-cancer drug. Antiseptic also. It is antiseptic property also. Septic property means it having antibacterial property. It is related to antibacterial property. So biological properties of furan is similar antimicrobial property. And it means antifungal and antibacterial properties, and having some anti-inflammatory properties. Anti-inflammatory properties. Next one, it having some anti. It is used as antidepressant also. So next one, thiophene. So thiophene generally it having it is it having anti-cancer activity, anti-malarial activity also, antimicrobial activity. Antimicrobial means antifungal and antibacterial activity. So it having the best property, that is estrogen receptor regulator. Estrogen receptor regulator. Okay, so these are the best biological activities of these three compounds. So generally heterocyclic compounds having, and these are active biological active compounds, but these three compounds having these kind of biological properties. Next we will go for preparation and properties. Okay. Sorry. Okay. So preparation and properties of these three compounds, that is furan, okay, furan and thiophene molecules. Okay, furan, furan, thiophene. So simplest. So first one is the we will discuss named reactions. These are the most important one. These reactions are very important in entrance examination. So Paul-Nahr synthesis. Okay, this is Paul-Nahr synthesis. So for Paul-Nahr synthesis, we are used generally the substrate molecule, reactant molecule is 1, 2, 3, 4, 1 and 4. 1, 4 dicarbonyl. Simply we can say 1,4 carbonyl compounds. 1,4 carbonyl compound, dicarbonyl or carbonyl compound. It is with ammonia. So the 1,4 dicarbonyl compound heating with ammonia about 280 degrees centigrade forming furan. This is the simplest method. So they have so mechanism also very simple one. For example, right. So this is the polar carbon. So electronegativity of oxygen is very high when compared to carbon atom. In between two atoms, carbon and oxygen atom, have a double bond. So electronegativity of oxygen is more, therefore then the 5 electrons moves towards oxygen atom. Simply, this particular carbon gets positive charge, oxygen gets negative charge. Okay. Sorry. So the ammonia attacks a particular carbon atom. So I can show like this. This is the place. This particular oxygen, negative oxygen mentioned here, and this is the carbonyl system. Next one. So the valence of nitrogen enhanced from 3 to 4. So for sake of stability, it loses each place ion. It is taken by oxygen atom. It becomes OH, oxygen with O minus converted into alcohol, and H and H valency decreased to 3, and this is the carbonyl system. Further, this lone pair of electrons attacks on carbonyl system. Then involved in cyclization becomes O minus. So we have 2 hydrogen atoms, valence is 4. Okay. Similar mechanism, the hydrogen atoms move towards oxygen atom. So I can mention like this. It is converted into OH. The new hydrogen atom comes an oxygen atom. So the valency come back to 3, 4 to 3. Okay. So the valence, nitrogen valence is 3, right? So this is the alpha position, this is the beta position. So beta carbon contains 2 hydrogen atoms. One of the hydrogen removed. Okay. Beta elimination takes place. So removal of 2 water molecules. Okay. So then form a pyrrole. Simple mechanism. Most important one, very famous reaction. So this is the Palmer synthesis. Okay. So similarly, by this way, we can prepare furan also. So in case of furan molecule, by using Palmer synthesis, the substrate molecule is 1,4-dicarbonyl compound, similar compound. So here also 1,4-dicarbonyl compound. Here also a 1,4-dicarbonyl compound. Okay. So reagent is different. For pyrrole molecule, we have used ammonia. In case of furan molecule, generally we are using H2SO4, sulfuric acid, or P2O, phosphorus pentoxide. So then forms a furan. Okay. So similarly, by this way, we can prepare, thiophene also. So for thiophene, in Palmer synthesis, the reagent molecule is it is common, that is carbonyl compound, 1,4-dicarbonyl compound. Then instead of P2O5, we are using P2S5. P2S5 is the reagent molecule. Okay, this is the thiophene molecules. So in Palmer synthesis, what is the reagent molecule under 20? So you can simply say 1,4-dicarbonyl compound is the substrate molecule in Palmer synthesis for pyrrole, furan, and thiophene also. So reagents are different. So for pyrrole molecule, ammonia is the reagent. So in furan molecule, P2O5 or H2SO4 is the reagent. For thiophene molecule, P2S5. This is P2O5, and this one is the P2S5. So differentiate oxygen and sulfur atoms. Okay. So in case of this is the reagent molecule. Reagent molecule for pyrrole, furan, and thiophene. Okay. Mechanisms are very similar. Next one is from mucic acid. From mucic acid. Yeah. Right. Second method is preparation of Sorry. Right. Okay. From nucleic acid. From nucleic acid. So nucleic acid contains 6 carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms with the 2 carboxylic acid functional groups. In polymer synthesis, 2 carbonyl compounds, 1,4 carbonyl system. In case of nucleic acid, COOH, COS, 1, sorry, 1,4 dicarboxylic acid system, that is COOH and COOH here. Remaining carbon atoms contains OH functional groups. Every carbon with functional group is functional groups. First and sixth carbon with carboxylic acids. Second, third, fourth, fifth carbon atoms with hydroxy functional groups. Okay, so similar reagent we have used, that is ammonia. Ammonia is the reagent for pyrrole molecule. So we can use alumina also, Al2O3. Okay, sorry, ammonia along with the alumina about 400 degrees centigrade. Okay, so few nucleic acid with ammonia or alumina about 400 degrees centigrade form a pyrrole 2 carboxylic acid. Pyrrole 2 carboxylic acid. Okay, so this carboxylic acid is removed by heating about 200 degrees centigrade. Remove as CO2, then forms here pyrrole molecule. This is the method for preparation of pyrrole molecule from nucleic acid. In case of furan molecule, similar way, this is the nucleic acid molecule. The 4 carbon atoms with the OH functional groups. Okay, so this nucleic acid heating with H2SO4, then forms here furan 2 carboxylic acid. So we cannot prepare the thiophene by nucleic acid. Okay, most important one. Which compound will not prepared from nucleic acid? A, pyrrole, B, furan, C, thiophene molecule. Thiophene. So from nucleic acid, acid, we cannot prepare thiophene molecule, but it is possible by using this one. So furan 2 carboxylic acid, furan 2 carboxylic acid heating with barium sulfide, simply I can get thiophene molecule. So thiophene molecule. So the byproduct is BaCO3. So 2 from carboxylic functional group, another from cyclic system. CO3, barium carbonate, sulfur instead of oxygen into cyclic system. Okay, this is this method is used for preparation of pyrrole, furan, thiophene. So we can prepare directly from nucleic acid. The pyrrole is directly prepared from nucleic acid, also furan, but thiophene directly will not be from nucleic acid, but indirectly we can get it. Okay, so next method is simple one, stellene one. From stellene molecule, stellene, the structure of stellene is, sorry, Right. Okay. Okay. Sorry. Right. So Stalin molecule. Stalin molecule. This is the Stalin molecule. Okay. So from Stalin, we can prepare the role molecule. So the simple reagent is NH3 molecule required 2 moles of Stalin. Okay, 2 moles of Stalin. Heating passes through red hot tubes. Hot tubes. Okay. So Stalin molecule, Stalin gas and ammonia gases passes through red hot tubes. Simply we get the role molecule. So similarly, by using Stalin molecule, 2 moles of Stalin molecule, sorry, I cannot prepare fuel by this method. So in case of thiophene molecule, okay, 2 moles of thiophene molecule and H2S gas, these two gases passes through red hot tubes or passes over aluminum about 400 degrees centigrade, will get thiophene. So the which molecule will not get directly from Stalin molecule and question butter and simply you can write for, you can vote for furan molecule. So by this way, from Stalin molecule, we can prepare pyrrole as well as thiophene molecule. In case of pyrrole molecule, the reagent is ammonia. Ammonia is the reagent. For thiophene molecule, H2S gas, hydrogen sulfide is the reagent. Sorry, next important question is, important method is NAR synthesis. Important method is NAR synthesis. Not a Paul NAR synthesis, simple NAR synthesis. So in NAR synthesis, we can use, this is the ester group CO280. This is alpha. We can mention amino. This one is beta position. Beta keto alpha amino beta keto esters. Alpha amino beta keto ester reacts with ethyl S2 acetate, reacts with ethyl S2 acetate, forms pyrrole derivative. Pyrrole derivative means pyrrole with different groups on different carbon atoms. Okay, this is the pyrrole group. Okay, next one. So we can prepare pyrrole derivatives, sir. So alpha amino beta keto is the reactant molecule, and ethyl state and alpha amino beta keto is the reactant molecule. On heating, we get pyrrole derivative. Similar way, we can prepare. Sorry, same. We cannot prepare it by this method. Furan cannot prepare by this method, and thiophene also cannot prepare by NAR synthesis. Next one is the hand job synthesis. This is the most important reaction. And HAN and jobs. HAN TJ and Josh and just synthesis. Okay, so the reactant molecule ethyl acetate, ethyl acetate CH3, AC2, acetate, acetate, plus with alpha haloketones. Alpha haloketone means suppose this is the keto group. So this is alpha carbon atom, chlorine atom, non-alpha carbon atom. That is known as alpha chloroketones. With ammonia, heating with ammonia forms pyrrole derivatives. Pyrrole derivatives. So by this way, we can prepare furan also. But nomenclature is different. Instead of Hanja synthesis, so this is known as feast binary synthesis. So in this method, we are using ethyl acetoacetate and alpha chloroketones. Alpha chloroketones, ethyl acetoacetate reagent is NaOH. It acts as base. So reactant molecules are same: ethyl acetoacetate, ethyl acetoacetate, alpha chloroketone, alpha chloroketone. Ammonia is the reagent for pyrrole preparation. Sodium ethoxide is the reagent for furan preparation. Okay. So for pyrrole preparation, name of the reaction is Hanjab synthesis. For furan preparation, the name of the reaction is feast binary synthesis. ఇక్కడ కాన్సన్ట్రేట్ చేయడం వాడి రియాక్షన్ ఇచ్చి పాల్నార్ సింథసిస్, ఏ పాల్నార్, బి నార్ సింథసిస్, సి హ్యాంజప్ సింథసిస్, డి ఇస్ ద feast binary synthesis అన్నాడు అనుకోండి. సో క్వశ్చన్ find out the name of the following reaction and question. But that reaction is EAA plus alpha chloroketone. Suppose this is NaOH. ఇక్కడ ఏమొచ్చింది బిడ్డ, ఇట్లా వచ్చింది అనుకోండి. సో ఏ పాల్నార్ సింథసిస్, బి నార్ సింథసిస్, సి feast binary synthesis, డి Hanjab synthesis. ఇట్లా అనుకోండి. సపోజ్ మీరు ఇది కాన్సన్ట్రేట్ చేయండి, ఇది కాన్సన్ట్రేట్ చేయండి, ఇట్లా ఉందనుకోండి. ఓకే సరే. Right. So you can tick for feast binary synthesis. So క్వశ్చన్ ఇట్లా పడ్డది అనుకోండి, ఇది తీసేసేయండి. Instead of this one, mention ammonia అన్నాడు. Instead of furan molecule, compound is derivative అన్నాడు. అప్పుడు ఏం పెడతారు? Hanjab synthesis. You can tick for Hanjab synthesis. Okay now. So you have to concentrate questions like we found questions like this. So suppose the question is, so what is the reagent? ఇక్కడ తీసేసేయండి. Another type of question like this. So this is the product. So what is the reagent for following reaction and mention చేసినప్పుడు, సో ఇక్కడ సారీ ఏ అమోనియా, బి H2SO, C NaOH, D NaOH. Okay. Find out the reagent for following reaction అని అన్నప్పుడు ఏం చేస్తారు ఇక్కడ చూసి బ్లైండ్ టెక్నిక్ ఏం పెట్టుకుంటారు అంటే పిర్రోల్ వచ్చినప్పుడు ఎప్పుడు కానీ రియేజెంట్ అంటే బ్లైండ్ గా అమోనియా పెట్టేసేయండి అమ్మా, ఏం ప్రాబ్లం లేదు, సింపుల్ గా ఇది పెట్టేసేయండి. ఇక నెక్స్ట్ ఫ్యూరాన్ వస్తే బ్లైండ్ గా H2SO4 పెట్టండి, కాకపోతే ఈ రియాక్షన్ లో మాత్రం
జగదీష్ సార్
NaOH. సో ఇక్కడ సపోజ్ ఇది
జగదీష్ సార్
so the reagent is ethyl acetate alpha chloroketone and product is the furan derivative. Furan derivative is the product. Sorry. Right. Furan derivative is the product. This is the product.
జగదీష్ సార్ జగదీష్ సార్
Okay, furan derivative product అంటే NaOET mentioned. So these are the named reactions. The most important reaction for only furan molecules, that is for furan molecule particular reaction from riboses, carbohydrates, ribose is the monosaccharide, ribose with H2SO4. Okay. For furan. This is common nomenclature for this compound is perfuran. If you are for furan. Okay. So this one is the most important. So we can prepare furan derivatives from carbohydrates. Suppose this is the 5-membered carbohydrate. So 6-membered monosaccharide is hexoses. 6-membered carbohydrates. The same reagent, that is H2SO4, will get some tetrahydrofuran derivatives. CHO, CH2OH. Okay. Sorry. This is the derivative. Okay. Next one is particularly for thiophene molecule. Thiophene molecule, we can prepare N-butane 1, 2, 3, 4 carbon atom plus it is heating with mercaptan, that is 4 moles of sulfur. This is the sulfur molecule heating a 65 degrees centigrade forms thiophene. So these are the specific reactions for furan and thiophene. Furan prepared from pentose sugars and hexoses, thiophene from simple alkenes, saturated compound, that is N-butane. N-butane heating with sulfur at 65 degrees centigrade forms thiophene derivatives. These are the preparation methods for these 3 systems, that is 5-membered system, that is furan, thiophene molecules. Okay, and then go for properties. We have 2 kind of properties. One is physical property and chemical properties. So we will discuss these properties with comparatively. Right. First one, we have furan, thiophene. Hey, Babu. Okay. So properties, physical properties. One is first one, color of the compound. Color. Generally, pyrrole molecule is colorless. Is also colorless compound. Colorless compound. This is also colorless compound. So these three compounds are colorless. But these compounds, particularly these compounds, generally exist in brown color. So this is due to aerial oxidation. Aerial oxidation. This is due to aerial oxidation. Actually, these three compounds are colorless, but furan and pyrrole molecules looks like brown color because of aerial oxidation. So similarly, similar to phenol molecule. Generally, phenol is colorless compound. It's shown like pink color or brown color because of uh, it involved in aerial oxidation reactions. Next one, the most important property is solubility. So solubility of compounds. The first one, it is insoluble. This compound is insoluble in water, but soluble in organic compound. It is soluble in organic compound, insoluble in water. Similarly, furan also insoluble in water, but soluble in organic solvents. So the specialty of thiophan molecule is it is soluble in water and organic solvents. So it is soluble in water. Which compound is insoluble in water and question better than soluble in water and A pyrrole, B furan, B furan, C is the thiophan molecule. Which compound is soluble in water and question better? You can take for thiophan molecule. Which compound is soluble in water better than soluble in organic solvents ante A pyrrole, B furan, C thiophan, D ABC and so which compounds are right? Sorry. Sorry. Okay. Right. Uh, this is pyrrole molecule. This one is furan molecule. This one is thiophan molecule. Okay. First one, the colorless. But these two compounds looks like brown color due to aerial oxidation. Second one is solubility. These two are insoluble in water, but thiophan soluble in water. They are soluble in organic solvents. The most important question is boiling point. So generally, boiling point of pyrrole is 129 to 131 degrees centigrade. For this one, 31.3 degrees centigrade. For this one, 84 degrees centigrade. So this one 84 degrees. So write the order of boiling point for 5-member system అన్నాడు అనుకోండి. ఫస్ట్ వన్ పెట్రోల్, థయోఫిన్, and furan molecule. This is the order for boiling points. So here petrol having more boiling point when compared to furan and thiophene. Itla question పడ్డది అనుకోండి. So the high boiling point due to intermolecular hydrogen bonding. So the bonds looks like this. This is the purol molecule. Undergone is the purol molecule. Okay, the interaction between hydrogen and nitrogen. Hydrogen of one molecule, nitrogen of another purol molecule. So interaction between two other purol molecules with hydrogen atom. So this is the hydrogen bond. So high boiling point of purol molecule is due to hydrogen right. This is about the boiling point. Next one, melting point. So generally petrol melting point is minus 23 degrees centigrade. These molecules having low melting points. This is about 85 degrees centigrade. This is about around 38 degrees centigrade, minus 38 degrees centigrade. So very low boiling point furan molecule. So which compound having low boiling point and melting point and question button? Immediately you can mention furan molecule.
Furan.
Okay. Right. Next one is properties, chemical properties. బాబు ఓకేనా, ఫాలో అవుతున్నారా?
Yes, sir.
ఆర్ ఫాలోడ్?
Yes, sir. Followed.
అమ్మా నేను రెస్ట్ తీసుకుంటారా? కంటిన్యూ చేయాలా?
Yes, sir.
ఒకసారి చాట్ బాక్స్ లో మెన్షన్ చేయమా. ఓకే, కంటిన్యూ చేద్దామా? ఒక 5 minutes రెస్ట్ తీసుకుందామా? Will we take 5 minutes rest? Yes or no? Okay for rest or continuation?
Wow.
ఓకే అమ్మా, ఒక్క 5 minutes తర్వాత మళ్ళీ జాయిన్ అయిదాం. ఓకే, మీరు కూడా రిలాక్స్ కండి. ఒక 5 minutes తర్వాత కంటిన్యూ చేద్దాం. రైట్. ఓకే స్టార్ట్ చేద్దామమ్మా. ఓకే, ఆర్ యు రెడీ? అఖిల, బిహేరా, పరంజ్యోతి, హర్షిత, రమేష్, నవీన, మేనక, ఐశ్వర్య. హూ ఇస్ ఎస్? ఎస్ ఎవరమ్మా? పేరు పూర్తిగా రా- సాయి, వర్ష, అబ్దుల్ కుద్దూస్, రామాంజీ. ఓకే రైట్. సో నెక్స్ట్ one, physical properties, the compounds with mineral acids. Okay ma, compounds with mineral acids. Suppose Pirra is very sensitive towards mineral acids. So in presence of H plus, it converted into polymer, that is trimer molecule. The trimer molecule. Okay. So like this. Right. This is the trimer molecule. Suppose in case of furan molecule with mineral acids, H2SO4, HCl, HNO3, CH3COH, phosphoric acid, whatever it may be. So sorry. Right. So first one, hero molecule. Second one is furan molecule. Third one is pyruvic molecule with mineral acids. With mineral acids. So becomes primer which is looks like then in so hydrogen molecule is very stable. It does not react with neutral acids. It is very stable towards H plus ion or OH minus ion. But pyrrole molecule with base it becomes pyrrole. Okay, so it does not react with base. Okay, so this is these reactions towards mineral acid and bases. Right. So next one is chemical properties. Generally, chemical. Okay, so pyrrole, furan, thiophene, these compounds are aromatic compounds. So generally aromatic compounds having cyclic in structure and conjugated bonds, and it obeys a cable 4 and plus 2 by electron group. So according to the structure, it's not obey the electron, but so these two electrons involved in conjugation. Two 5 systems, 2 plus 2 electrons plus 2 electrons, total 6 electrons. 4 into 1 plus 2, 6 electrons. It obeys the 6 electron system. Next one, cyclic system with conjugation. Okay. So these are the two aromatic compounds. So all aromatic are participates in electrophilic substitution reaction. Electrophilic substitution reaction, like benzene. So this is the particular property for aromatic compounds, that is electrophilic substitution reaction. Okay, so for example, I can mention heteroatom with X. So X having lone pair of electrons, 2 electrons, and 2 from this pi bond and 2 from this pi bond. So 6 pi electrons. Okay. So, for example, this is the benzene. The 6 carbon atoms are similar carbon atoms. Therefore, the electrophile, we can mention E plus electrophile attacks on any one of the carbon atoms. There is no difference. But in case of heterocyclic systems, clearly these two carbons are differentiated with each other. You see this carbon atom directly attached with heteroatom, so these carbons are called alpha carbons, and the next carbons are attached with alpha carbon, that is known as beta carbons. For sake of our convenience, I can mention alpha and alpha dash, beta and beta dash. So finally, every 5-membered heterocyclic system compound having two kind of carbon atoms. One is alpha and beta carbon atoms. Suppose if the electrophile attacks on alpha carbon atom, we get alpha substituted carbon. If the electrophile attacks on beta carbon atom, it is related to the beta substituted. These two compounds are different because the IUPAC nomenclature is different. Okay, this is one substituted compound, this one is the two substituted compounds. Whenever the IUPAC nomenclature is different, the compounds are different. Okay, suppose right. The product system. This is electric substitution reaction. The electrophile replaces the electrophile. It attacks alpha carbon atom. Okay, X. It means this pi system moves towards alpha carbon atom. Alpha gets positive charge, negative charge, and this carbon gets positive charge. Then only this carbon attacks an electrophile. Okay, that's right. Like this. This is not less one. This is the intermediate. This one, the intermediate. If the electrophile attacks on beta carbon atom, which means, sorry, suppose these 5 electrons moves towards beta carbon atom. So the carbon system, the carbon particularly this carbon atom.
ఎక్స్క్యూజ్ మీ సార్ సార్ మీ వాయిస్ సరిగ్గా రావట్లేదు కొంచెం క్లారిటీగా చెప్తారా
So the electrophile attacks on this beta carbon atom. So in these cases, the intermediates are different. So you substituted intermediate. This is the substituted intermediate means first heteroatom is 1 number, 2 number, 3 number. So this is 2 substituted, and this one is 3 substituted intermediate. In these 2 intermediates, which is most important one? Which one is most important one? ఓకే అశోక్ సార్ క్లాస్ లేదమ్మా పిల్లలు ఇవాళ అశోక్ సార్ క్లాస్ లేదు ఎగ్జామ్ ఉంటుంది ఈ క్లాస్ అయిపోయిన తర్వాత ఇంకొక 1 hour లో క్లోజ్ చేసేస్తాను మీకు హెట్రోసైక్లిక్ సిస్టమ్ గురించి హెట్రోసైక్లిక్ కాంపౌండ్స్ మీరు వెయిట్ చేయాల్సిన పని ఉండదు నెక్స్ట్ డే క్లాస్ని సార్ తీసుకుంటారు మీకు ఒక ఎగ్జామ్ కండక్ట్ చేస్తారు సార్ ఓకేనా
Okay, sir, continue.
Okay. So in these 2 compounds, suppose this is unstable molecule. Intermediates are unstable molecules because of these molecules having these are the charged particles. So this unstable intermediate stabilized by resonance. It means you get a resonant structure. It's positive charge. Okay. Next one. This is lone pair of electrons on conjugation. Get another resonant structure. Right. Okay. For this molecule, sorry, I can mention X. For this molecule, the lone pair of electrons moves towards the second carbon side. We'll get the resonating structure like this. Okay. So in these two cases, first case means electrophile attacks on second one. The intermediate is unstable. It is stabilized by resonance. Finally, we'll get 1, 2, 3 resonating structure. In second case, the electrophile attacks on third carbon atom. This unstable intermediate on resonance will get only 2 resonating structures. Therefore, the first case is more stable. More stable means the majority product is electrophile attacks on second carbon only. Okay, so you can note this point. First point is aromatic compounds. Aromatic compounds are participates in electrophilic substitution reactions. So all heterocyclic compounds are an aromatic compound. Therefore, heterocyclic compounds are participates in electrophilic substitution reactions. So, we can question about heterocyclic compounds. What type of chemical reactions in heterocyclic compounds are important? Electrophilic substitution reaction, electrophilic addition reaction, nucleophilic substitution reaction, elimination reaction. Simple electrophilic substitution reactions. In 5-membered system, so electrophile attacks on two substituted substitution is more favorable than the substituted product. Substitution. So heterocyclic compounds involved in electrophilic substitution reaction. So electrophilic substitution reaction is more favorable in heterocyclic compound at second position than third position. Okay. So suppose this is the heterocyclic compound. Okay. For example, X reagent, chlorination reagent, we get two products. One is two substituted product, yes, another one is the three substituted product. In this case, which is more favorable product and atom? This one is the suppose we have to take 120 molecules, 100 molecules, 150 molecules. Every molecule would be was these are the 100 reagent molecules, 100 to 120 substituted molecule. First 100 molecules participates. In first 100 molecules, the chlorine attacks at second position. The remaining 20 after 100 molecules, after 100 completion, the remaining 20 molecules, the chlorine attacks on third position. Okay, means this this position. Whenever two, these are the above 500. This is 120. Next one, 400. So chlorine. Okay, these two alpha positions are blocked. Then the chlorine attacks on third position. After that only, first of all, chlorine attacks on this position. Second chlorine attacks on this position. Third chlorine attacks on this position. And fourth chlorine attacks on this position. So this is the more favorable. Whenever these two positions are blocked with the substituents, then only go on third and fourth position, that is beta positions. So electrophilic substitution reaction at second position is most favorable. This is the most important one. Okay. Next one is, so electrophilic substitutions reactions. First one is nitration reaction. Second one is sulfonation reaction. Third one is halogenation reaction. Halogenation means chlorination, bromination, etc. So, first of all, for pyrrole molecule, in case of pyrrole molecule, suppose the common nitration reagent is concentrated HNO3, 1:1 molar ratio of concentrated HNO3 with concentrated H2S. This is the common reagent. Generally, what we expect that the nitro group attacks on second position. The expected product is like this, but the reaction takes place. Why? Why? I get answer. What is responding? Wait. All you people completed degree BSc. Already have studied heterocyclic compounds. My question is, why nitration reaction does not take place on pyrrole molecule by using nitrating reagent such as concentrated HNO3 and concentrated H2S. Please mention answer. The answer is already we discussed. Okay, so suppose please give me the answer for the pyrrole molecule with mineral acid. What will happen? Is it ఏమైతుంది
Primer.
mineral acid. What are the mineral acids? H2SO4, HNO3, H3PO4, HCl, acetic acid. These are the acids, common acids. So I get answer that is primer. Very good. For furan molecule, what will happen? Navina, Vidar, what about furan? What will happen with the mineral acids? Polymerization. Good. Okay. In case of furan molecule, in presence of mineral acid, polymerization takes place. For pyrrole molecule, trimerization takes place. So actually, in a nitration reaction, we come back to our nitration reaction. The reagent molecules are nitric acid and concentrated sulfuric acids. These two are mineral acids. So in presence of mineral acids, the pyrrole molecule involved in trimerization instead of nitration reaction. Are you understand? అర్థమవుతుందమ్మా? ఇక్కడ ఏమవుతుందంటే జనరల్ గా pyrrole molecule mineral acids తోటి trimerization అవుతుంది. నైట్రేషన్ లో మినరల్ యాసిడ్స్ ఉన్నాయి, నైట్రిక్ యాసిడ్ అండ్ కాన్సన్ట్రేటెడ్ సల్ఫ్యూరిక్ యాసిడ్. ఇట్ మీన్స్ సో ఇక్కడ నైట్రేషన్ వి ఎక్స్పెక్టింగ్ దట్ ద ప్రోడక్ట్ ఈస్ nitrobenzene, but we'll get trimer only. It means it involved in polymerization reaction instead of nitration reaction. Okay. So in presence of mineral acids, pyrrole involved in polymerization reaction formed trimer product. But we want nitrobenzene. Sorry, 2-nitropyrrole molecule. We expecting 2-nitropyrrole molecule. For this, we recommended to the reagent without mineral acid, means without the reagent could not produce H plus ions. For this, we are using CH3 COO NO. So NO is the plus, CH3 COO is the minus. So acetic acid, acetyl nitrate. This is known as acetyl nitrite. This acetyl nitrite is, it produces nitronium cation. This acts as electrophile. Then only produces 2-nitropyrrole. ఓకే, ఇక్కడ మీరు HNO3 H2SO4 కామన్ రియేజెంట్ వాడితే మనకి ట్రైమర్ ప్రోడక్ట్ వస్తుంది. ఇన్స్టెడ్ ఆఫ్ మనం ఈ నైట్రిక్ యాసిడ్ సల్ఫ్యూరిక్ యాసిడ్ బదులు నైట్రో ఎస్టేట్, దిస్ ఇస్ ద నైట్రో ఎస్టేట్ వాడితే అప్పుడు మనకు నైట్రో ప్రోడక్ట్ వస్తుంది. నైట్రేషన్ విల్ అకర్, బట్ the question is, the challenge is the reagent without H plus ion, without produce H plus ion. Okay, so this is the best reagent for production of nitronium cations. Okay, similarly the pyrrole molecule also right. Okay, the furan molecule. So nitration on furan molecule. Suppose the similar nitrate H2SO4 plus HNO3, concentrated nitric acid and concentrated sulfuric acid. You want to use this one. What will happen? It won't be done. What is going on here? When we add nitrating mixture to furan molecule, will we get nitrofuran or polymeric product? Answer is similar like nitration on pyrrole molecule with nitrating reagent. ఇక్కడ ఏం రాస్తారు? ఇది పాలిమరైజేషన్. ఇక్కడ పాలిమర్ ఏర్పడుతుంది, పాలిమర్ వస్తుంది. So what can we do for nitration on furan molecule? మనం ఏం చేయాలి? ఇక్కడ ఏం చేయాలా? Simple one. The reagent like without mineral acid, CH3 COO NO2, nitro estate. Finally, we'll get 2-nitro. Very right. This is the exact answer. 2-nitro. In presence of the particular reagent, that is, this is the reagent. So the reaction will fail in presence of nitration mixture. When we add nitro estate, we get nitro product. Okay. For thiophene molecule, so simple one. You can use HNO3 H2SO4 concentrated H2SO4. Simply we get nitro product. So it indicates that thiophene is less reactive when compared to furan and pyrrole molecules. Another indication is it is It does not sensitive towards mineral acids. మనం ఇంతకుముందు చూసినాం, లాస్ట్ టైం డిస్కషన్ చేసినప్పుడు థయోఫిన్ అంటే ఫిబ్రోల్ ఫ్యూరాన్ presence of mineral acid ఏమైతుంది, ట్రైమర్ పాలిమర్ వస్తుంది అన్న. presence of థయోఫిన్ ఏమొస్తుంది అన్న, థయోఫిన్ presence of mineral acid does not involve polymerization reaction. Therefore it looks like a benzene. It behaves like a benzene. Common organic compounds, common aromatic compounds. Okay, looks like common aromatic compounds. The property, chemical property behaves like common aromatic compounds. Right. Next one, sulfonation reaction. Sulfonation reactions. Sulfonation. For example, this is the fibro molecule. So for sulfonation in aromatic compound is reagent is concentrated. What is the problem? What is the product? What is it? Okay. చెప్పండి బిడ్డ. Fibro molecule and sulfuric acid. The product is what we expecting? Fibro to sulfonic acid. But what will we get? What will we get? Primer. Navina. Okay, primer is the product. Why? Similar answer. In presence of mineral acid, it is involved in polymerization. These two molecules involved in polymerization. So it is rectified by using the reagent. So that is pyridine sulfur trioxide. Pyridine sulfur trioxide or sulfur trioxide in presence of pyridine molecule. This is the best reagent. Actually, structure of pyridine looks like presence of sulfur trioxide. It generates SO3 plus. So it attacks on SO3. This is the neutral electrophile. So attacks on second position of the molecule. Will get sulfur trioxide, pyridine molecule will get SO3H. So pyridine H here. Pyridine 2 sulfonic acid. This is the IUPACE now. So azole 2 sulfonic acid. 2 azole sulfonic acid. Azole 2 sulfonic acid is the IUPACE. Two sulfonic acid. Similarly, SO3 in presence of pyridine. So furan. This is the sulfonic acid. This furan 2 sulfonic acid. So, but in case of thiophin molecule, simple reagent that is concentrated H2SO4 will get thiophin 2 sulfonic acid. It is looks like common normal aromatic compounds. Okay. Next one is the halogenation reactions. Best example for halogenation is chlorination reaction. In case of the molecule, simple one, general chlorination on aromatic compound. The reagent is chlorine, Lewis acids. This is the reagent. the common area for chlorination on aromatic compounds. This Lewis acid is prorogues the polymerization reaction. Therefore, we are using using without acidic reagent, that is SO2Cl2, presence of SO2Cl2, or chlorine in presence of phosphorus. These two are best reagents for chlorination on pyrrole molecule. So actually, this is more reactive molecule. We get over chlorinated product. We get over the same time alpha positions, one of the beta position also done. So this is the one product, and also the product like this. This is the first product. Second product. Generally, we are expecting two chloro molecule, only one substituted molecule. But here we get different products with different chlorine atom attacks and different positions of pyrrole molecule. Okay. Next one, in case of thiophene molecule, similarly, furan molecule, same reagents. So we'll get at the same time the 4 carbon atoms of furan molecule blacked with chlorine. So it indicates that furan is more reactive than pyrrole molecules. In case of thiophene molecule, generally it is very safe towards mineral acid. It is inert towards mineral acids. Therefore, we are using common reagent, that is chlorine in presence of AlCl3. So we get or disubstituted thiophene molecules. This is the best way for the preparation of thiophene chlorination. Similarly, bromination also takes place. Okay. Next is particularly the pyrrole molecule. Pyrrole molecule involved in three-month-timer reaction will get different products. Okay. We get two kind of products. Generally, an aromatic compound or benzene molecule reacts with three-month-timer reaction. The general reagent is chloroform. CHCl3, presence of KOH base, strong base. This is the strong base. This is the chloroform molecule. So, in presence of chloroform, in presence of KOH, generates CCl2, dichlorocarbon. This is the neutral electrophile. What is the electrophile? In Raymer-Taymer reaction, benzene gun, chlorine gun, you can mention dichlorocarbon. Dichlorocarbon is the neutral electrophile. Electrophile means electron deficient species. It doesn't have any charge, therefore it is known as neutral electrophile. So attacks on carbon. The pi system attacks on carbon. Okay, these are the reactions. Another most important reactions are reductions and oxidation reactions. Simple. Suppose pyrrole molecule. This is the pyrrole molecule. For furan molecule. This is for thiophene. Okay, right. So reduction with suppose first one, reduction with sodium metal in presence of ethyl alcohol. EOH means C2H5OH. This is ethyl alcohol. Will get simple complete reduction, which involved in complete reduction. Sorry. Right. Right. So it involves in complete reduction. Next one here. Suppose presence of zinc acetic acid, COOH, acetic acid, ACOH. Presence of zinc metal is different. Here we are using sodium metal. Second one, zinc metal. We get different kind of products. This is partial reduction. So this kind of products. So this is partial reduction product. This one is the complete reduction product. This reagent is more reducing power when compared to zinc acid. So in presence of sodium ethyl alcohol, tetrahydropyrrole molecule, dihydropyrrole molecule. These are the dihydropyrrole. Right. Similarly, in case of furan molecule, okay. Okay, this is the furan. Furan is good. Furan is good. Hydrogen and oxidation. Sorry. Nickel. Tetrahydrofuran. మొత్తం hydrogen double bonds with tetrahydrofuran. Suppose platinum ACOH is acetic acid. This is acetic acid. అప్పుడు మనకేమొస్తుంది? 4 carbon atoms, 1 carbon, 2 carbon, 3, 4 carbon atom, 2H. Simple butane. A regular question. So furan presence of platinum and acetic acid finally bond cyclization is destroyed and forms butanol. So ఇక్కడ తీసుకుంటే థయోఫిన్ మాలిక్యూల్ తీసుకుంటే సోడియం లిక్విడ్ అమోనియా తీసుకుంటే లిక్విడ్ అమోనియా partial reduction the molecule dihydrothiophene molecule. Suppose while we are using nickel, ran in nickel. Okay, so nickel is the reducing agent. So ఇక్కడ వాడినామంటున్నాం డబుల్ బాండ్ కొట్టుడు పోతే సల్ఫర్ కూడా పోతుంది ఇన్ బ్యూటేన్. ఇది కూడా మోస్ట్ ఇంపార్టెంట్ రిడక్షన్. So these two reactions are most important according to examination point. Okay, these are the reduction properties. Next one, oxidation properties. So generally, oxidation reactions. Okay, here CR3 oxidation 2, 5 also. 5 also product. We get 5. Suppose furan is there in presence of aerial oxidation, we get bridged like carbon. Because partial oxidation, it approaches a bridged like product. Peroxy bond is there. This is aerial. Just a few years calculation. In presence of any version, ethanol in air and water, ethanol in air. This kind of product we will get. This is one of bonus. Okay. Okay, sorry, Amma. Sorry for the disturbance. Okay, right. Suppose for thiophene molecule, the thiophene molecule, the aerial oxidation, general oxidation is there. The oxidation will take place on sulfur. Third oxidation at sulfurylase is known as sulfur. Sulfurylase. So reactions. There are these are the most important oxidation reactions. Okay, this is about the oxidation and reduction reactions. Okay, next one is sorry. Right. The most important one is comparative study. Okay, so already let's see. So structures of compounds. This is the five-membered system. So it is looks like this. Sorry. అర్థం అవుతుందా అమ్మా? రైట్, ఇక్కడ చూడండి. సో 4 carbon atoms, 1 2 3 4 carbon atoms. This is the whether it is pyrrole molecule, it is nitrogen. In for pyrrole molecule, this one is oxygen. Diaphene molecule, this is sulfur molecule. So these 4 carbon atoms, these 4 carbon atoms involved in sp2 hybridization, including heteroatom also, whether it is nitrogen, oxygen or sulfur atoms. So all these atoms involved in sp2 hybridization. So in case of sp2 hybridization, 3 sp2 orbitals and 1 p orbital is there per carbon atom. So these three, every carbon having 4 electrons in outermost uh, two in ground state. So the sp2 three sp2 orbitals occupied with 3 unpaired electrons and p orbital also 1 unpaired electron. So the 3 electrons that is one distance. Suppose sorry. వాయిస్ వస్తుందమ్మా? క్లియర్ ఉందా వాయిస్? నాకు Right. Okay, Amma. Okay. Right. Right. These four carbon atoms. So these four carbon atoms. Right. So these four carbon atoms involved in sp2 hybridization. These 5 atoms involved in sp2 hybridization. 4 carbon atoms means, so looks like this. The carbon this one, this one. Clear? So this is the one orbital, sp2 orbital. This is the one of the sp2 orbital. Sorry, this is one of the sp2. So one of the sp2 orbital overlapping with another sp2 orbital of another adjacent carbon atom. So one other sp2 orbital with adjacent sp2 orbital of adjacent carbon atom. So next one is another with hydrogen atom. Okay, 3 sp2 orbitals. This is adjacent carbon atom. This is also overlapping with adjacent carbon atom. This is overlapping with adjacent carbon atom. So the p orbital, this is p orbitals. These are all p orbitals. Yeah, right. So these are the p orbitals. These p orbitals, particular p orbitals, these particular p orbitals overlapping with each other. So these p orbitals are overlapping with each other and form a pi bond. For nitrogen atom, so nitrogen having 5 electrons in outermost orbital, 3 in carbon atoms. Sorry, it involved in sp2 hybridization. These 3 sp2 orbitals with 1 electrons and another p orbital occupied with p electrons. This is the p orbital, so it is occupied with pair of electrons. So these electrons, these electrons involved in nitrogen overlapping with adjacent carbon, 2 adjacent carbon atoms and 1 hydrogen atom. So the p orbital involved in overlapping involved in resonance. So we can get resonance hybrid. So 1 electron, 1 electron, 2 electron, 3, 4 electrons plus 2 electrons, 6 electrons. So these 6 electrons overlapping with each other and generates a and form a aromatic sextet. This is the right. This is the structure of the molecule. Okay. Sorry. Right. The aromaticity. So right on delocalization, will get different resonating structures. So general aromatic order. So write the aromaticity and అనుకోండి. Aromaticity order means so thiophene having more aromaticity when compared to pyrrole when compared to furan molecule because of heteroatoms are different in case of thiophene. Sulfur, pyrrole, sulfur in thiophene, nitrogen in pyrrole, oxygen in furan. So oxygen electronegativity is more than that of nitrogen and nitrogen electronegativity is more than that of thiophene molecule. So whenever the electronegativity is increased, the electron pair donating nature is decreased. Therefore, the availability of electrons for resonance, it is decreased in oxygen. So availability is less in oxygen when compared to pyrrole nitrogen and when compared to thiophene sulfur atoms. Therefore, so delocalization is very easy in thiophene molecule because of low electronegativity of sulfur molecule. So delocalization power of very low in furan molecule because of high electronegativity of oxygen atoms. So it delocalization power తగ్గిపోయింది. So resonating aromatic sextet generation is very weak in the furan molecule, very high in thiophene molecule. Therefore, it is more aromatic. This is very less aromatic when compared to these two atoms. So whenever the aromaticity is more, the stability will also increase. So vice versa, it is more stable. Furan thiophene molecule is more stable. So aromaticity order is thiophene is more than furan. Similarly, stability order also same. It is resemble with aromaticity property. So next one is order of stability, thiophene, pyrrole, and furan. So next one is boiling points. So already boiling point of pyrrole is more because of hydrogen bonding. So reactivity order, stability of furan is less reactivity, therefore the reactivity less stability, therefore its reactivity is more. It is related to stability. Reversible property, reverse property of stability. Stability is more, reactivity is less. Stability is high, reactivity is stability is less, reactivity is more. So stability of thiophene is more, therefore reactivity is less. So furan stability is less, its reactivity is more. Evidences for reactivity. So mineral acids, it involved in polymerization. It is more reactive, so it is less reactive. Just it involved in trimerization. It is very less reactive, therefore it does not involve in polymerization reactions. Next one, fluorination reactions. So furan, simple reagent that is the dichloromethane molecule produces tetrachlorofluofuran molecule. But in case of pyrrole molecule, it requires strong reagent than dichloromethane, that is chlorine in presence of phosphorus. Then only it gets tetrachlorofluoral molecule. Thiophene molecule is very less reactive when compared to pyrrole molecule on fluorination reaction. Produces only monofluorothiophene molecule. The reagent is same in pyrrole and thiophene molecule, but in case of pyrrole, it produces tetrachloro, but thiophene molecule produces only monofluoro molecules. Okay, so whenever the temperature increases up to 50 degrees centigrade with similar reagents, that is chlorine and phosphorus molecule, produces two substituted, okay, 2 and 4, 5, 2 and 50, 2, 5 dichlorothiophene molecule. Okay, disubstituted, we'll get disubstituted molecules. So this is the nitration reaction. So furan molecule is very reactive, therefore it doesn't react with it. Doesn't the mineral acids are not safer for nitration reaction on furan molecule because of it involved in polymerization reaction due to high reactivity of furan molecule. So the mild reagent without hydrogen donor, that is nitroestate. Presence of nitroestate, furan produces nitro molecule. Similarly, pyrrole produces nitro molecule, but yield of product is less when compared to furan molecule. So thiophene molecule, thiophene is very stable when compared to these two molecules, then only produces nitro molecule, this common nitrating reagent. Sulfonation, similarly, already we have discussed it in previous classes, previous slides. Next one, Diels-Alder reactions. Diels-Alder means the dienophile. This is the adductor. So this is the dienophile reagent molecule. So furan molecule, generally the Diels-Alder property is Diels-Alder reaction 1,4-diene. 1,4-diene in presence of succinic anhydride produces adductor. So the furan molecule in Diels-Alder reaction, it behaves like a normal diene only. Understand? ఇక్కడ ఫ్యూరన్ మాలిక్యూల్ ఉంది కదా, ఇక్కడ దీంతో డైనోఫైల్ తోటి మామూలుగా డైన్ ఎట్లా రియాక్ట్ అవుతుందో 1,3 డైన్ ఎట్లా రియాక్ట్ అవుతుందో అట్లనే సింపుల్ రియాక్షన్, సింపుల్ గా 1,3 డైన్ లాగానే రియాక్ట్ అవుతుంది, ఓల్ఫిన్స్ లాగా రియాక్ట్ అవుతుంది అనమాట. ఇక్కడ తీసుకున్నట్టయితే దాంతో రియాక్ట్ కాదు ఓల్ఫిన్స్ లాగా, కాకుండా ఇదేమవుతుంది అంటే డిఫరెంట్ జస్ట్ అడిషన్ ప్రోడక్ట్ లాగా వస్తుంది అనమాట విత్ నైట్రోజన్. సో దిస్ ఇస్ ద బెస్ట్ ఎవిడెంట్ ఫర్ స్టెబిలిటీ or reactivity of pyrrole and furan. Furan is more reactive, it behaves like diene. This is less reactive, it does not behave like diene, but it produces addition product. This produces addition product. Okay, thiophene, it is very less reactive, therefore it does not react with the diene, that is dienophile, that is succinic anhydride. So this is the another best evidence for stability of furan, pyrrole, thiophene, and reactivity of pyrrole, furan, thiophene. Okay, this is the comparative study of these three compounds. Okay, ఏమా ఫాలో అయిందా, అర్థమైందా ఏమన్నా? ఓకేనా బిడ్డ? సో ఇది హెట్రోసైక్లిక్ కాంపౌండ్స్, ఒక పిరిడిన్ మాలిక్యూల్ ఉంది. నెక్స్ట్ క్లాస్ లో నేను దాన్ని టైం తీసుకొని అది కూడా జస్ట్ 40 minutes, హాఫ్ అన్ అవర్ లో కంప్లీట్ చేసే ప్రయత్నం చేస్తాను. మీకు ఇప్పుడు అశోక్ సారు టెస్ట్ పెట్టే ఛాన్సెస్ ఉంది. ఓకేనా? థ్యాంక్ యూ. నేను అశోక్ సార్కి పంపిస్తాను.
థ్యాంక్ యూ సార్.
సార్ సార్ ఒక ఇది ఏమైనా టెస్ట్ కింద ఉందా సార్? ఇప్పుడు 8:30, ఇప్పుడు దీన్ని క్లోజ్ చేయడమేనా సార్?